The last major concepts that were covered in lesson 2.1b would be the ideas of what is linear versus what is nonlinear. So again, because this is another type of concept, I need you to know I'm going to use a different highlighter to highlight this T-chart. So when you go back and study this sheet, it's a little bit more easy for your eyes to focus. So when we look on the left-hand side here, we're talking about the word linear. Definition. The definition of linear is that it's data in a straight line. So the word in here should be straight. Data in a straight line. So that means your data points are usually connected by a straight line. That line can be a straight horizontal line. It could be a diagonal line that's going in the positive direction, or it could be a diagonal line that's going in the negative direction. As long as it is a straight line, it is called a linear function. Some key characteristics that linear functions have is that they have a common difference. And common difference, as we've been talking in your math talks and then just in general, this vocabulary word comes from Unit 1. But a common difference is, remember, when you are adding or subtracting the same number every time. So if we go back to your summary notes or your first page of your summary notes, remember this linear pattern had a common difference of adding 4 each time. Your common difference can be either adding the same number every time or subtracting the same number every time. Another key feature of linear functions is that it has a constant slope. So have a constant slope. So in order for it to be linear or graph a linear line, your slope has to be consistent so that your points or that your data is going up by the same rate every single time something changes. Therefore, when I look at this table, I can see some of the points or my output values aren't filled in, but I have some output values to work with. So with my other color, I'm going to start by looking at -4. When I look at -4 and I head to -1, because I know linear functions have to have a common difference, I'm looking what number being added or subtracted to -4 gets me to -1. And that to me is by adding 3. So if I'm at -4 on the number line and I add 3, I end up at -1. Just like if I'm at -1 and I add 3, I end up at 2. And 2 plus 3 then is 5. So to continue my pattern forward, 5 plus 3 gets me to, I should switch to this color, 8. And then 8 plus 3 is what gets me to 11. So then if adding 3 going forward is my pattern to help me fill in the missing pieces behind, I need to think the opposite or subtract 3. So -4 minus 3 would have me end up at -7. And -7 minus 3 would have me end up at -10. So then to double check moving forward, -10 plus 3 is -7, and -7 plus 3 is 4. So again, this is technically an arithmetic sequence because I'm adding the same number every time, which means it has a common difference or that pattern of +3. And simply if I look in the X row or my inputs, I notice that my pattern is adding 1 each time. So I could continue that pattern all the way through. So my point that I'm getting at is in order to be a linear function, you need to have an adding or subtracting pattern, which we call a common difference, in your table. If it's not an adding or subtracting pattern, then it's not linear. Graphs. When we look at linear graphs, they have to be straight lines. So they have to either go in the positive direction, negative direction, or have a slope of 0. Therefore, if I were to graph a positive linear line, I would need to make sure that it is rising from lower left to upper right. So this line that I kind of just sketched in here is a positive linear line because it's straight and it's going in the positive direction. Likewise then, a negative line would be falling from upper left to lower right because it's decreasing over time. So this is a negative linear line. And then finally, to have a slope of 0, you need to have a straight across horizontal line. And so that is an example of a horizontal line that doesn't have a slope, but yet it is still linear. Finally, equations of linear functions are equations that don't have exponents that are higher than 1. So for example, all the equations that we wrote earlier, or functions I should say, f of x equals negative 5 over 12x plus 35, and f of x equals 4x plus 2. These are both linear functions because when I look at the x variable, they do not have an exponent higher than 1. Technically, their exponent is 1, but we don't write that in. And so because there's no other exponents, that would be a linear function. So another example of a linear equation or function would be y equals negative 10x minus 2. Another example could be y equals 5. That would be a straight horizontal line at y equals 5. Another linear equation could be negative 6x minus 12y equals 24. So even though this equation isn't solved for y yet, we'll eventually remind ourselves of how we do that and get into how we get this equation solved for y. But when we do, I will see that it will end up in y equals mx plus b form. Therefore, let's jump into the nonlinear functions. Nonlinear functions are data not in a straight line. So a key characteristic for that, or for nonlinear data, is that there is no common difference. Therefore, if nonlinear data has no common difference, what they do have is a common ratio, or they could have a common ratio. So they could have a common ratio. They could have what's called second difference. Or they could have no pattern at all. So to summarize that, nonlinear functions do not have a common difference, meaning they do not have adding or subtracting patterns. They have what's called either a common ratio, a second difference, or no pattern at all. And these are characteristics that we're going to continue to explore not only in this unit, but in our units that are to come in second semester.